So now let's see, we have done 5.1 and 5.2. Now, when we're doing 5.1 and 5.2, we were given X values, or we are given Z scores. So they gave us X values, they gave us Z, or they gave us Z scores. All right. And then 2, we were asked to find the area, or same as find the probabilities. So they gave us X values, or they gave us a Z score, and then they asked us to find the area or to find the probabilities. Now, what we did was that we drew like a diagram. We drew a cute diagram. We say, for example, this is A, this is B, and then we shaded given area, and then we use the we use the we use a normal CDF, which we put in the A, we put in the B, we put in mu, we put in the sigma to find the answer. So this is what we've been doing so far, right? They give us X values, which could be the A and the B, and then we use a normal CDF to find the probability. Okay, so the whole of the last lecture, that is the kind of things that we're going through to find the probability for a given X value or given Z score. Today, we're going to do the reverse of this. In other words, now you're going to be given the area, and then you are going to ask to find the X value or the Z score. So under 5.3, you are rather given the area, or you're given the probability, and then you ask to find the X value or the Z score. All right, so that is what we will be doing today. You are given the area, and then they say find the X value or find the Z score. How do you go about it? All right, that's what we're going to be doing. So our lecture today will be of this form. Let's say you have the mu in the middle, and then perhaps you are given this area, and then they will say what X value or what Z score matches that. So this is a question mark. So this is given. This is given. All right. And then so area given, and then they ask you what X value will give you that. Now, in order to do today's lecture, we need a different function. All right. So in terms of TI-83, TI-84, we're now going to be using another function, and that function has a special name called inverse norm. So we're going to use a function called inverse norm. All right, the function we'll be using is called inverse norm. Now let me quickly show you that, if I can, hopefully. So on the calculator, clear, second quit. So we're going to second press the vars. The inverse norm is usually the third function, invNorm. And then when you click, it asks you for 3 information: the area, the mean, and then the standard deviation. So that is the function that we're going to be using, the inverse norm. All right, so I just want to let you know. Okay. All right, so let's go back to what we've been doing. Now, for us to use the inverse norm. Let me explain this to you first before we proceed. So usually when you have the bell curve, and then so let's say we have the bell curve. Let me draw this line. So we are looking for whatever value is here. Now, this line that I have set up as, actually, let me draw a new one here because that could make more sense. So let me draw a new one here. So let's say this is a mean, and let me just draw a line somewhere here. And then we are looking for what X value, what Z score goes with this line. As far as this line that I've just drawn, the green line you have here is concerned, there is a left side of a line, and then there is a right side of a line. So we have the left side of this line, and then we have the right side of this line. On the left side, I'm going to call it the left area. And the right side, I'll call it the right area. So when you hear me saying right area, then I'm looking to the right side of a line. Now, these left area also come with another name sometimes. Actually, sometimes we call it the bottom, and the right area is called the top. So when a question says the top 10%, let's say top 10%, it means the bottom 90%, right? So a top 10%, for example, means the bottom 90%. Okay. So the right area can be, identified, sorry. The right area can be identified as the top something percent. The left area can be identified as the bottom something percent. Now, another word that we can use for the left area, it's percentile. Like the PF percentile. So when we say a percentile, we are referring to the left area to the left of that line. All right, so percentile means the left area. All right, so knowing these few things, let's see how we can put this into work. So I've already told you the function that we are going to be using. It's the, not always, it depends upon the question, and we would look at some questions you would see. Yes. So the function we'll be using in the TI is inverse norm. The inverse norm gives you either a z-score or an x value. All right. The inverse norm takes in three information. It takes the left area, the mean, and then the standard deviation. All right. So the function we are using is called the inverse norm. The inverse norm can give you x values when you just have a regular normal distribution, or it could give you a z-score when you have standard normal distribution. Right? So because standard normal distribution, the variables are the z-score. The regular normal distribution, the variable are the x values. All right. Now, the inverse norm takes in three information. Number one, so the input for the inverse norm, number one, it takes in the left area or the left side, all right? The percentile. It only takes in the value of the left area. So whatever number you put there, it may be thinking that you are putting in the value for the left area. And we would look at some examples that can help us understand these. I just want to point out that when you put a number there, the computer doesn't know what you put there. It only assumes that the first value you put there is a value from the left area. All right. Now, also remember that areas are probabilities. So area is probability. Probability, right? Probability is between 0 and 1. So let's say if your area is 90%, you are not going to put 90 there because 90 is more than 1, right? You're going to put 0.9. So the areas are also probabilities. Okay, so you change it into decimal before you plug in into the calculator. It asks for the left area. Number two, it asks for the mean, which is mu. And then number three, it asks for the standard deviation, which is sigma. So the inverse norm will ask you for three information. The percentile, which is the left area, the mean, and then the standard deviation. So those are the three things the inverse norm would ask you to input. Right? And I've also always said that the left area is the same as the PF percent. So P, the left area, the mean, and then the standard deviation. Okay, so why don't we now look at maybe a problem here. So let's look at this, what is happening here. Now, so over here, what we have is like a couple of diagrams. Let's see what the question says. So question said that you should find z-score. We've been told that this is standard normal. Remember that when they tell you that something is standard normal, right? They expect that you should know is normal distribution with a mean of 0 and a standard deviation of 1. So the moment they mention the word standard normal, you should know for sure that you're dealing with a mean of 0 and a standard deviation of 1. Okay, now standard normal deals with z-scores, right? So in here, we can look at what is happening. So, and that is why it says we should find z-scores, because standard normals deals with z-scores. Okay, now when you look at the diagram for question 1, you would see that the line that has been given, this line, it's left area, right? What has been shaded is the left area. So we have left area. Left area is 0.2810. So this is okay. We always want to make sure that we have the left area. All right. So because this is okay, all we're going to do is to say that the z-score we are looking for will be the inverse norm. Inverse norm. Now, if you do on your calculator, you say, what is the area? So area, put in the 2810. Then the mean, say, what is the mu? Put in 0 because standard normal. And then what is the standard deviation? Put in 1. So could someone do this so you could tell me what the answer would be? So go to second verse. Second verse. Yes, Alex, what do you have?
It's negative 0.579873.
So we could say negative 0.58. Number one, that is correct. We are expecting a negative answer because the line is below 0. So we are expecting a negative answer. The reason why I wrote just 2 decimal places because z-scores, right? Z-scores are written in 2 decimal places, right? Areas are written in 4 decimal places, but z-scores are written in 2 decimal places. So if you create a z-score, always change it to a 2 decimal place number. So that is very good. Now let's look at question 2. So here in question 2, they given line is here. The given line is here, and they want us to find what is the z-score that will be under this line. Well, they gave us the right side. So the right side is given, or I will say I'll call it the right area. All right. Now, if the right area is given, then the left area will be 1 minus the value of the right area. In this case, 9564. So somebody should tell me what the value of the left area would be. And you could put it in the chat if you know. Okay, Amber, can you tell me please?
Is it 0.0436?
Good. It's 0.0436. So we're going to say that the z-score we are looking for will be the inverse norm, the area. So when we say area here, we mean the left area is 0.0436. The mean is 0. The standard deviation is 1. And someone could do the calculation, so you could tell us and we'll write the answer. All right, so Isabella. Wait, Isabella, yes. Yes.
Negative 1.71.
Okay, negative 1.71. That is absolutely correct. Beautiful, beautiful, beautiful. So note that you only put the left area into the calculator. All right, let's look at the next question, question 3. So in question 3, looks like they did us a favor by giving us already things on the left. So in question 3, we have the left area happen to be 0.6628. So we say our z-score will be the inverse norm. Then the area is 0.6628. The mean is 0. The standard deviation is 1. And Miss Luna, you could give us the answer.
Okay, hang on. Point 420.
So you say point
Point 420.
42, right?
Yeah.
Someone confirm that answer for me, please. Someone confirm the answer.
It's correct.
Okay, thank you.
You're welcome.
All right. So now we are going to look at the next set of questions. Okay. First, this question says we should find the z-score, and then they give us a percentile. Now, percentile, so 90th percentile is the same as 90% left area. All right, 90th percentile is the same as 90% left area. Well, always draw your bell curve. One of the beautiful things about statistics is that we draw relaxing curves that relax our nerves, right? This is like a therapy section. So it's wonderful. I love to draw bell curves. It's like, it's so cute. Okay. So let's see. This is 0 here because they said it's standard normal. The reason why they said it's standard normal for us to remember the mean is 0, the standard deviation is 1. So now I have to ask myself, where can I put a line that will represent 90% left area? Would it be below 0 or would it be above 0? Someone tell me where I'm going to put that beautiful line. Okay, Luna, what do you have? You said it would be Okay, I couldn't hear you. There was a little noise from the background. Luna, I did not hear you because there was a little noise from the background. Okay, so what we could do is, okay, no problem. So Amber, can you tell me?
What was the question again?
I said, where would we put a line that would represent 90% left area?
I don't know, sorry.
Okay, Ellen, would it be
Below.
below 0 or above 0?
Below.
You said below. I have my
Yeah.
doubt. 90% left area.
Oh, above.
Okay, so we can put it somewhere here, right? We want to draw the line so that there is more space on the left, about 90% space on the left, right? So we definitely have to put it over more than 0 line so it will make a reflection. So it means that the left area will be 0.9, right? The left area will be 0.9. So we would do, so the z-score we are looking for, the z-score will be inverse norm 0.9, 0, 1. And someone work this out and tell us the answer. Luna, since your hands is still raised, maybe you say you're in public area too, right? So we can ask somebody else then. Chad? Yes.
I have 1.28.
Okay, and that is correct. 1.28. Very good. All right, let's look at the next question. Well, they want us to find a z-score for 30th percentile, which means 30% left area. So always draw the bell curve. All right, that's our therapy section. Let's draw a bell curve. And it's standard normal, so I can put a 0 here. So this time, where would we put the line that will represent 30% left area? Andrew? Is Andrew there? Andrew, usually when I call you, don't respond, I think. All right, anybody could answer that question. Where would I put a line that is 30% left area? Okay, Chad.
To the left of the 0.
Excellent. Because we just want 30%, right? So there should be more percent, about 70% right. So we would say that the left area will be 0.3. So our z-score that we are looking for will be inverse norm. The area is 0.3. The mean is 0. Standard deviation is 1. And then we look for the answer. Okay, Ellen, what did you get? You said, how do we know which side it is? Okay. So Ellen is asking, how do we know? So let's get the answer first, and I'll answer that. Okay, Madison.
Is it B?
You are absolutely correct. It is B. Good. All right. So this line is negative. This line is negative 0.53. This line was 1.28. 1.28. Okay, so the question on the table is, how do we know which side is the line? Now, let me just make a little analogy here, right? Let me make a little box. Suppose the box is 100%, but I want to split it in, and then the middle is there, right? I want to split it in such a way that I get 90, let's say 90% to the left. The new line I should draw should be somewhere here. It should be more than the middle because I want more. 90% to the left means only 10% on the right. 90% left, 10%, 90% left, then 10% on the right. So I want to draw it. So when we drew this, we have only 10% on the right, but we have 90% on the left. So you draw it in such a way that if the left is more than 50, it definitely has a middle line. If the left is less than 50, it should be below the middle line, technically. Okay, let's look at the next question, question 3. So they tell us that the 7th decile. Now, decile means you have broken things into 10 parts, 10 equal parts. So decile is what percent left area. Could someone tell me what you think the 7th decile would mean in terms of left area or percentile? Okay, so who raised a hand? Okay, Malcolm.
Would that be the 70th percentile?
Absolutely correct. So this is 70% left area or 70th percentile left area. All right. So when we draw the curve, and this is the middle, we want a line that will represent 70% left area and then 30% right area. So that line should come after 0. Right? Because there should be more on the left side than on the right side. So this is 70%. So left area is 0.7. All right. And you are always interested in the left area. Your interest is always in the left area. Interest is always in the left area. So in this case, the z-score we're looking for will be the inverse norm. Then we have 0.7, 0, 1, and I don't know what that will give you. We are expecting a positive answer because the line is a little bit above 0. So anyone will work it out for us? Angel, today I want you to contribute. Okay, someone give me the answer. So Chad, what do you have?
0.52.
Yes, that'll be actually 0.53 if you round it, right? So that will be C here. Okay, so these are the kind of things we're gonna do. Let me also say this before I move to the next slide. Now, you see how I talk about 7th decile? It could maybe say 3rd quartile. If the question says quartile, then we mean 75% left area. If the question says 1st quartile, then it means 25% left area or percentile. So the Q3 is the same as P75. We use P for percentile. And then Q1 is the same as P25. All right. So the quartiles, the decile, they all means area, or they all mean left area. All of them means left area. Okay, let me take an actual question for us. Okay, so let's look at this beautiful question we have here. Now, so in this question, let's first make sure they would indicate certain key things we want to hear. Number one, they say it's normal distribution. So we say, hooray, that's great. They gave us the mean, and then they gave us the standard deviation. So let me write out the information. So we know it is normal. We know the mean is 50. So definitely it is not standard normal. It is a regular normal. Then the standard deviation happened to be 10. Now the question says that the area that we need to draw the line from, or the line we need to draw, is the top 10% line. The top 10% line, right? It says we should find the value. What is the lowest score? We're looking for the score. So actually, we are looking for X value in this case. So X value is what? Okay, first step, draw the bell curve. So let's draw the bell curve together. Draw the bell curve, have a beautiful middle to match, and put the mean in there. The mean is 50. So this is always the starting point. Now, we need to draw a line for the top 10%. So, Chris B, where am I going to put that line? Above 50 or below 50, Chris?
Above 50.
Excellent. The top will be above 50. Great. So this line is the top 10%. Now, top 10% means a left area of what? Anyone? Amber? Top 10% means a left area of 90. Alex, that is correct. Thank you. So that will be 0.9, right? That will be 0.9. We are always looking for the left area. So once we get the area, we love it. So we're going to say that the value we are looking for, which is an X value. Now, how do I know it's an X value and not a Z score? One, because when you're dealing with a normal distribution, a regular normal distribution, it deals with X value. When you are dealing with a standard normal, then you're dealing with the Z score, right? So the X value will be the inverse norm. Then we put 0.9. The mean is 50. Standard deviation is 10. So this time we put in the information that they gave us. And let's see, someone would do the calculation. Let's see what you will get. Anyone doing the calculations for us? Okay, Isabel.
I got 62.86. I mean, no, I mean 0.82.
Okay, very good. So 62.82 is the answer. Very, very good. Very, very good. All right, so what we did, they are all here. All right, very good. So the lowest score that you need for you to be in the top 10, especially for this particular example, is roughly about 63.